All right, let's do this. Hello, everybody, and welcome. So I'm doing this video basically to show you guys how to do some video analysis as well as how to do Google Sheets. Now, some of the motions you're going to see here are kind of complicated. I know some of you have taken physics in the past, so this isn't going to be really anything new to you. Those of you who haven't taken physics in the past, don't worry about some of the terms and yeah, don't worry too much about all I'm doing here is just trying to get some data so that we can play around with data on Google Sheets. The goal here is to be familiar with Google Sheets as well as video analysis software. It's not to define terms of position, displacement, velocity, all that. We're going to define that later on in the week and next week. So don't worry if this is all over your head right now. The goal is video analysis and using Google Sheets. And I'm going to try and move as quickly as I can here so that this video is not too long. All right, so I got a video here. Here, I'll show you what the video looks like. There's me. Back in the classroom, back in the day. And oh, cart went up, it sped up, and then it slowed down. So it sped up and slowed down. So those of you who've taken physics before, you might not have seen motion like this, really. Or we would have to have, back in the day, we would have to split that thing up into, speeding up, and now it's changing, the acceleration is changing, it's slowing down, et cetera, et cetera, et cetera. So what we're going to do is we're going to try and model this motion by using this video analysis software. And then we're going to kind of try to create an equation that's going to model that thing. Let's see what that looks like. Okay, so this is called Logger Pro, and you got, you can see a little graph here. It's got a vertical, whoops, sorry, it's got a vertical axis, it's got a horizontal axis, and so I'm going to start up with this video analysis software. I'm going to take my video. How I got this video is I downloaded it onto my computer, and then I went Insert, Movie, and then I grabbed it. So it takes a little while to load up, which is why I had it loaded up at the beginning. And now I'm going to take my video and start at where I started the car moving. So let's see. I got to have my hand off the car. So we'll start at, let's say about right there. So I'm going to start the car right there. Notice I've also got a meter stick in here. I got a meter stick in there. And so I'm going to start my analysis now. So the car's about to move. It's about to move. And so I'm going, and I go down, see where my mouse is? My mouse is down where these three dots are. In the lower right corner, I click on that. And this little toolbar shows up. So one of the first things I want to do is establish my origin. So that's this icon right here. I'm going to click on it. It says Set Origin. I click on it. And then typically what this is going to do is literally it's going to create an axis. It's going to create an axis, or however that, X and Y axis. So let's see, and I got my little cursor here. I like to put it in the lower left corner always. So something's kind of interesting about this car right now is it's moving to the left. So there we go. I see that yellow line. There you go. I just generated my axis right there. Next up, I'm going to now I'm going to let this thing know. This thing says Set Scale. That's the fourth icon down. I click on that, and now I'm going to basically click on one end of the meter stick here, and then drag it all the way to the other end of the meter stick like that. And basically this thing's asking, is that 1 meter? And I say, yes, machine, or, program, that is 1 meter. And I go, okay, that's 1 meter. So now it knows how many pixels essentially is a meter inside this video. Okay, now I'm going to go finally to this icon which says Add Point. So when I click on that, and then I pick some point on the car that I think is useful. So notice my cursor is a little off the car. That's why I'm using though the front wheel. I'm using the front wheel right here. But if I did this, I kind of cover up everything. So if I do this, I can get an idea of where the car is in the horizontal direction. Okay, so I'm going to click once. Oh, and did you notice? Did you see it? It moved. I click again, it moved. I click again, it moved. I click, I click, I click, I click, I click, and I click, and I click, and I'm hoping it gets a little further along here. Let's get it when it's moving a little faster here. Let's do maybe oh, there you go. Okay, there you go. It's probably moving a little faster here. Boom, I click, I click, I click, and you can see my dots are more spaced out than they were back here, because back here, but every time I click, the frame is moving forward one frame. So I'm clicking and it's moving forward one frame, and I'm clicking and it's moving forward one frame. Yeah, there we go. And well, if I look at my graph is going to look terrible. Let's look at what a real graph might look like. Let's see, open recent. Where did I do that? Was it this one? Yeah, this one. No, don't save any of this. This is garbage. All right. This is going to take too long to load up. All right, it took a little too long to load up, so I'm just going to move on to this. So this is the data that I collected from it. If you notice, I got time. So this is the time at which I on the video where I started collecting data, and this is the position with respect to the axes that I made. That's telling me where the car is. So at 7.76 seconds, the position was 3.4 blah 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 meters. I don't even need that many, but it's all right. So, and then at this time, here was the position. At this time, this was the position. At this time, blah, 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 blah. And I got 93 data points. That's a lot of data points. I did a lot of clicking right there. So, yeah. And then also I've got the time over here, same time. But this is the, on this column, we got the velocity, which is in the units here are meters per second. Meters per second. So position is just meters. And then velocity is meters per second. And then, so some things to notice here. The time started at 7.76 seconds, right? Why would I do that? Well, because I started collecting data when the video was at 7.76 seconds. Or the velocity here is negative. Why is it negative? Well, for those of you that, again, this is not a big deal if you don't know exactly what I'm talking about. We'll talk about it all later, but I'm just, for people who do know, here's a bit of review, right? Why is the velocity negative? Well, which way did the car go? The car went to the left. So yeah. So the car went to the left. So if the car went to the left, then there you go. You get a negative velocity. And then for position, the position's positive because it was to the right of my origin that I set. Remember, the origin I set over into the lower left corner. All right. So before I get to graphing, though, so we got time and position here, time and velocity here. Before I get to graphing, I want to show you guys a little bit of how useful Google Sheets can be. So let's say for some random reason I wanted to make a let's do time. Let's say I wanted to make a new time. I'll call it T prime. And the new time, this is not even going to be a real time. I wanted to do the operation 1 over the square root of the old time. So I'm going to do this new time, T prime, which is not even a time because the units don't work out, but don't worry about it. We're just playing with Google Sheets. Let's say I want to do 1 over the square root of T, right? Well, I've got 95 data points. That means I would have to do that operation 1 over the square root of T 93 times. That would be a nightmare. You probably don't want to do that. This is where Google Sheets comes in handy because I'm going to go equals and then 1 over. So, okay, sorry, so I'm going to use this time here, right here. And in order to do this, so I'm just gonna do the operation once. So I click this box down here. So here's where I'm doing the operation. I've got V, that should be T. I'm gonna do the operation 1 over T to the power of 0.5. Okay, so I'm gonna do 1 divided by, now I want though this time right here, this time, 7.76, but it's on the, and so I'm gonna identify, well first I'm gonna open parentheses. I'm parentheses crazy when I deal with stuff like this. So now though you want to choose the column and row of the number that I want to do the calculation for. So this column is column F, so F, and then row 2. So F2, that's that cell number. Whoop, I didn't hit equals. So let's go again. So I'm going to hit equals 1 over, open parentheses, F2, That's the cell. Notice it highlights it, says, hey, is this the cell you're talking about? Yes, it is the cell I'm talking about. Thank you very much. And I'm going to do to the power. That's the little caret symbol, the little, right there. So you hit Shift 6 for most keyboards will do that. So I do a little caret symbol, and then I'm square rooting it, so it's to the power of 0.5. So I hit 0.5, and then I close parentheses, and then I hit enter, and there you go. That's just 1 over the square root of 7.76. Now if I wanted to do that, now what I'm going to do is I'm going to click the cell again. I'm going to click the cell again, and then I bring my mouse over. See how it's turned in from when I bring it to the lower right corner there, it turned from an arrow to a plus sign. I then click and hold, and then I drag it all the way down. And I let go, and there you go. Google Sheets just did the operation of 1 over the square root of whatever cell this corresponded to and gave me the answer. There you go. 93 times. Or 92, I guess, right? Because I did it the first time. So it just did the operation over and over and over again. Yeah, so it just did it over and over and over again. It did it for all those times. So there you go. There's that. Okay. So this is something I want to see that you turn in with your homework. Is that everybody has this column over here with the operation 1 over the square root of this time of that time, and then that operation was done all those times down there like that. So basically, when you turn in your assignment, I'm going to open it up, and then I'm going to look for, did you do the operation, right? I'm not asking you to do the operation 92 times. I'm asking you to do it once and do the drag down thing, and then I'm going to check to make sure that, hey, yeah, you did that. Cool, nicely done. All right. Next up, what we're going to do is we're going to graph position versus time. So in physics, in science, we do the vertical versus the horizontal axis. So position versus time. That's what we're going to graph here. And the way you do that is, so right on the horizontal axis is the independent variable. The dependent variable is on the vertical. The way Google Sheets works is on the left side, you put the independent variable. On the right side, you put the dependent variable. So I got time on the left, position on the right. All you got to do is highlight both columns. So I just did that. I highlighted both columns. Go up to this icon right up here. It says Insert Chart. Looks like a chart. There's other ways to do this as well. I like to just go to the Insert Chart. I click on that, and nothing happens. Oh, there we go. This is what you want. So you want what this is called a scatter chart. This is called a scatter chart. Hopefully you get that. So if not, you can go down over here, and it says chart type. So, and I could go to, oh, there we go. That's what I want right there. That position versus time. You don't want line chart. You don't want column chart. You don't want area chart. You want scatter chart. Scatter chart, because I got all those data points there. That's all the data points. I could probably clean that up a little bit, but I'm not going to bother too much about it. You got all these other ways that you can graph things, but scatter chart, that's what you want. Double check to make sure your everything is good here. So this says position meters versus time seconds. That's exactly what I want because I want a detailed title. I'm also going to add the position versus time of a pullback cart. Or car. Pullback car. There you go. Because you want it to be detailed. You want the graph to tell you information. This is a position versus time graph of a pullback car. And then on your axes, you want to make sure that you've got the dependent variable, which is position. You've got the units, which is meters. On the horizontal axis, you've got the independent variable. In this case, it's time, and that's in seconds. All that is good. So everything's good here so far. But if not, you can always change it. You can just click on it and change it. Let's see. So next thing we're going to do is figure out a way to model this. So how we're going to do that is we go down to, where this editor is, here's Setup. I'm going to go to Customize. I'm going to go to Series. Let's see. Let's change the point size. I'm not liking this point size. Ah, that's nice. Yeah, there we go. So there's all my data points. I just got so many data points, so I made them smaller there. So I go to Series, and I keep going down. I'm going to hit Trend Line. So I'm going to click on Trend Line. And my trend line, let's see, let's make the color obvious. So we're going to make it black. All right, so there we go. You can see I've made a, this is, oh, the type of trend line was linear. This is a linear trend line, a linear trend line. And then you're also going to go down to label. Instead of none, you're going to select use equation. So that's the equation of that trend line. And then lastly, I'm going to click on show R squared. So an R squared value is a value that basically tells you how good your line fits that data. So an R squared value, basically the way it works, I don't need this anymore. Basically the way an R squared value is, so for an R squared value, it's a number between 0 and 1. A number like 0, if I had a graph, would be the graph looking like this, and here's my trend line. This would be an R squared close to 0. But instead, if I had a graph that was close to 1, so instead, let's say I had data points and it went something like this, and then my value, this would be close to having an R squared value close to 1. So the closer the data fits to the line, or whatever trend you're making, the closer the R squared value is to 1. The worse, the more spread apart that data is, and it doesn't fit the line, the more that R squared is equal to 0. So it's always a number in between there. In physics, we tend to have really good R squared values. I'm not going to show you how to calculate that. For that, go ahead and take a stats class. But yeah. Okay. Whoop, that's me. Let's go back. Okay. So we see we got an R squared value of 0.991. Now, is that a bad R squared value? No, actually, that's a pretty good R squared value. And honestly, if we were modeling this with like maybe like in between here or something, we might be able to get away with it. That might be fine. But because we got all these little trailing off here, we got some, those of you who know physics, we got basically speeding up here and then slowing down. So, okay. That's not going to fit my data very well. Let's see. Let's instead, let's do, what kind of graph does this maybe look like? Well, you know what? This graph actually looks a lot like a quadratic. You could say it looks like, you know, other things, but I'm going to say, oh, I'm going to model this as not a quadratic, sorry, a cubic function. I'm going to model this as a cubic function. Now, how would I do that? I'm going to go again to trend line. Instead of linear, I'm going to say polynomial with a degree of 3, because a cubic function has a degree of 3, right? So there we go. And ooh, R squared value equal to 1. That is a good fit. Now, you can keep, well, I'm not going to go too deep into this. Generally in this class, we are going to create data that then fits a line. But there's when dealing with sophisticated software like this, oftentimes we model things by using, you know, polynomials or exponential. You could do all sorts of stuff. Okay, so there we go. We got our trend right there, and we even got an equation for this. The equation is, let me see, I'm gonna write it down. Come here, you. Come here, you. Wait, there we go. So I'm going to write down this equation. No! There we go. So this equation, so for the position versus time, the equation we got is, let's see, I'll write it this way, 0.196 x, or well, that'd be t, so t cubed, right, minus 5.47 t squared, and then over here we got 49.4, so plus 49.4 t, and then minus 142. Okay, so that's our equation. So, and then that's the position as a function of time. So that's the position. The position I'm calling x as a function of time. So it's an equation, and the equation looks like this. It's yeah. So there we go. And I'm placing T's instead of X's because Google Sheets just generally just writes X's as their variable. It doesn't know that, time is on the bottom here. So it just uses X's for its equation. Don't worry about it. Okay, so next up, let's see. Yeah, what the heck I'm going to do. So we're going to do this one more time. I'm going to do it a little bit faster here. So again, I'm going to graph this time velocity versus time. Boop, boop. So I'm going to highlight those two sections. That's what you're going to do too. And then I'm going to do insert chart. So here's my velocity versus time graph. Let's again, already this is scatter chart. It says velocity versus time. Velocity versus time. What is it though? It's for a pullback car. The vertical axis is velocity. That's correct in meters per second. That's my dependent variable. Time again is the independent variable and it's measured in seconds. Good. So yes, once again, make sure you got scatter chart, none of this other nonsense right here. The other thing I'm going to do, so I'm going to go to customize. Let's do series. And let's do again 2 point. There we go. So we got those little dots. That's nicer. Okay, and then now I'm going to, what does that look like? Yeah, that looks like a quadratic. That is more of a quadratic shape. So let's see what that looks like. So trend line, in this, linear. What do you think the R squared value would be for this linear trend line? Let's see. 0.02. That is not a good R squared value. That line, let's make that again black. That line does not fit that data at all. So that is not a good way, good way to write that. Now, I'm not going to go any further there. So let's see. Let's instead change it to polynomial. So I clicked on trend line. I clicked on linear. I'm going to go to polynomial, and the degree of 2. That's correct. All right, and then I'm going to change my label. Instead of custom, I'm going to do use equation. And now I got an R squared value of 0.967. Not bad. Not bad. That's good. That's pretty good. And so there we go. That's what I want here. So what I want you to do is to have what you're turning in is, well, I'll explain to you what you're turning in a bit. Let me talk about, I'll do my last spiel here is I'm going to look at all this. So there you go. That's all good. So, and then I'm going to do this equation. So this equation here, this is the velocity versus time graph. And the equation is, so starting with the x squared value or the t squared, so 0.528 t squared minus 9.85 t plus 44.5. And that's the velocity as a function of time. So those of you who do know physics and do know calculus, you know that a position function, that the velocity function is essentially the derivative of a position function. So if you do know calculus, or even if you if you do know calculus, go ahead and take the derivative of this function, and you'll see that you basically get that function with about a 10% error. I did it, and yeah, should be about a 10% error because we're dealing with real data here. But yes, if you take the derivative of the position function, you get the velocity function. And so again, if you haven't taken physics, don't worry. Just kind of an interesting little tidbit for people who have taken physics already or have taken calculus. Again, I teach you the calculus in the class, so don't worry too much about that. But if you do know that thing, you could take the derivative of the position function and you'll find out within a margin of error that you get the velocity function out of that, which kind of shows you the power of calculus. And now, well, no, I'm gonna I can ramble on and on for all this stuff. So let's see. Let's go back to what I expect from you. So here's what I expect from everybody. Everybody should have a position graph that's got a detailed title to it, that's got well-labeled axis with units. And you should have an equation and an R-squared value. For your velocity versus time graph, same exact thing. Should be a detailed title. Should be your labeled vertical and horizontal axis with units, equation, and R-squared value. So you're modeling velocity versus time as a quadratic, and you're measuring, you're doing position versus time as a cubic function. Then you can just leave it like this. In fact, this is fine because I can just look at it like that. And then off in this column, it doesn't have to be k, but it has to be somewhere to the right over here. You're going to do the operation 1 over the square root of t to the power of a half, or square root of that. And then I should be able to look through that and see that you did that. And now, let's say, sorry, one last thing before we go. Let's say that you went, oh my God, I don't know how to do, or let's say you suddenly forgot that you can write square root as power of 0.5. Well, you can go, let's see. How do I write? You go to Google, you go, how do I write square root on Google Sheets? So you just look that up and you go, let's see here. Let's see, Google. Yeah, that's probably a good place to look. Okay, I just use SQRT all in caps, and then I put what I want in the parentheses there. Oh, thanks. Okay, so let's see if we can do that. SQRT, can even copy that. And so let's do that again over here. And I'm going to do 1 over, so I'm just going to do the same operation. So equals 1 divided by, open parentheses, and I'm going to do SQ, or I'll just copy it. Now I don't want to do 9 though. I don't want to do 9. I want to do F2 again, F2. So F2, it's highlighted it. It says, is that what you want to take the square root of? Yes, Google, that's what I want to take the square root of. Let's close those parentheses up, hit enter. Hey, it's the exact same number. And then I can again click that cell right there, go to the lower right corner, it turns into a plus sign. I click, hold, and I pull all the way down. And it does it does the same exact thing. You can see those things are identical. Hey. So, yeah. You'll see in this class we'll have some things where we have lots of data, and you'll have to do operations on that data. Please feel free to use Google Sheets when doing this. Thank you. So yes, you should have just one column here. You don't need the other column, just one column showing me that mathematical operation. All right, see you guys. Bye.